Hi guys, I want to continue our discussion of similarity today. And just a quick reminder of what that means. If two figures are similar, then they have every corresponding pair of angles are congruent, and all pairs of corresponding sides are proportional, meaning they have the same ratio. If I divide one side by its corresponding one, then the same should happen for any sides of the figure. So we talked about that, and that's kind of common knowledge. The other thing I wanted to mention is that when I have any triangle, remember that whichever angle is the smallest angle, the side opposite has to be the longest. Okay, so for instance, if I knew that this were, say, 40 degrees, and this was 60 degrees, and this was 80 degrees, then I would know, based on this knowledge, that the length of side X is the longest, the length of side Y is the second longest, and the length of Z is the shortest, because Z is across from the smallest angle, Y is across from the second smallest angle, and X is across from the largest angle. And that's just a fact. It has nothing to do with similarity necessarily, but it's something that we can keep in mind, especially when I'm trying to determine if two triangles are when I'm comparing to whether they're similar or not. Let's look at an example real quickly. This is as simple as it can get. If I tell you already that these two figures are similar, that's what this means, then we can find the value of some missing side, because I know that the ratio of one pair of similar size or corresponding sides is the same as the ratio of the other. And I always want to check with the lettering, right? PL corresponds with WZ, and that makes sense based on the orientation of these figures as well. So I know that 26 over 78 has to be equal to 24 over C. I could write this another way. I could also write 78 over 26 equals C over 24. Either way, to solve this, I have to multiply, I have to cross multiply, which all that means, guys, is if I wanted to get rid of the 24 on the bottom of this fraction, then I would have to multiply by 24 on both sides. Right? In fact, I don't really even need to cross multiply. I just want to get C by itself. So the answer of C should be whatever 24 times 78 over 26 is. And I'll save you the trouble. That equals 72. Okay? If I look at the same problem on the right, but in a different setup, the problem is that C is on the bottom. So I would need to multiply both sides by C first, and then I would need, so this would give me 24 equals 26 over 78 times C, and then I need to divide by that, which means multiply by the reciprocal, which would be 78 over 26, and you can see how this is the same as what I had over here. One last thing, technically, since the ratios are the same, I could also have written this as 24 over 26 equals C over 78, because now I'm saying I want this side compared to this one in the same figure, but I still know that this first side corresponds with C and the second side corresponds with 78, and notice that they're still in the same position within the proportion. And to solve this, I would end up multiplying both sides by 78, right? And again, I would have 78 times 24 over 26, which is the same I had here and the same I had here. I probably took too long to go over that, but I think it's important that we understand that the proportion doesn't matter how I set it up. It only matters that I'm consistent in the way I'm comparing things. So I'll do this one a little quicker. We should know that 12 over 20 is the same as 2x plus 5 over 24. And one nice tip is it's nice to keep the x on the top if you can, because it's easier to solve that way. All I have to do is multiply both sides by 24. And so 2x plus 5 is going to be equal to whatever 12 times 24 over 20 is, which is actually 14.4. Whoa. Sorry about that. So that's 14.4 is equal to 2x plus 5. Then I would subtract 5 from both sides. I'm sorry, I'm going to write up this so I would have room. That is 9.4 equals 2x, and x is going to equal 4.7. Another quick thing to mention is theorems that work to tell that two triangles are congruent. And they're similar to what we know. If I ever have two angles, whether I have another side or not, or whether I have all three angles, if I know that two angles in one triangle are congruent to two angles in another, because I know the triangle angle sum theorem, that 180 minus those two angles also has to be true for both, then I know these triangles are similar. Similarly, if I have side angle side, if I know that one side of a triangle and another side of a triangle are proportional to another, not necessarily they're congruent, but as long as x over y is the same proportion as, say, z over w, if two sides follow the same proportion and the angle between them is congruent, then I know those two triangles have to be similar. I don't even need to know another angle or the third side. And I think this third one makes a kind of obvious sense. If I know all three sides follow the same proportion, then obviously they're going to be proportional. They're going to be similar figures. But the reason I bring this up is let's look at these two triangles on the right. Here I have 18 over 27. If I divided both by 9, it would simplify to be 2/3. If I compare 26 over 39, hope you can see this. If I divide both by 13, that simplifies to 2/3. So we know that this side is proportional to 18. 39 has the same proportion with 26. But the angle I know, 34, is not included. This would be a side angle. You can spell it backwards if you want. You remember from congruence that this doesn't work. And the same is true for similarity. Even though these two follow the same proportion, I would have to know either a third side or a second angle to know for a fact that these two things are actually similar. And we're going to look at some more examples of that tomorrow. Last, I want to talk about what I call embedded triangles. When you have two triangles that share the same line along two of their sides. Okay, I hope you can see from this that these triangles should be similar because they share an angle. The key is if I know that these two lines are parallel, because if they are definitely parallel, we went through this a lot last chapter, right, that angle is congruent to this one, which is already enough. That means angle, because I know the P up here is the same for both triangles. But I also know that this third angle is congruent to this one. So these have to be congruent. And when I say, it's not congruent, sorry, similar. And when I say the two triangles, we have to see that I have this triangle PST, but I also have this large triangle outside of it, PQR, right? And these two triangles have to be similar. This is why I say embedded, because this green one is embedded like inside this red one. Let me clean that up. But the key now is, since I know that PST, triangle PST, is similar to triangle PQR, now I can say that's in proportions, but I have to be careful. For instance, this 4 in PS corresponds not with 7. It corresponds with PQ. And PQ is this entire distance, not 7, but 11. So when I set up my proportion, then I go to PT, which is x over here, but PT corresponds with PR, which again, that is this entire length. It is not 12, it is x plus 12. Okay? So now to solve this, and this is really critical. If I write 12 here, I'll get the wrong answer every time. But now I can actually cross multiply. I'm going to multiply both sides by x plus 12. And that's going to cancel here. And I'm going to multiply both sides by 11. And that's going to cancel here. And I get 4 times x plus 12 equal to 11x. And now I can do some distribution. And I'm in great shape now. I got 4x plus, remember distributive property now. That's really important. 4x plus 48 equals 11x. If I subtract 4x from both sides, I get 48 equals 7x, which means x equals 48 over 7. Don't be afraid of fractions. That's a great answer. You didn't do anything wrong. And we're going to continue with this tomorrow and play with kind of all these ideas. Thanks.